Okay, welcome back to Organic Chemistry Decoded. We got another predictive product practice for you here. These are synthetic questions like you're going to see on your exam. So we have this alkene here, and we're asked, what is the product if we add Br2 in H2O for it? And for the sake of this, we're going to say there's a phase transfer catalyst, just to make sure that all this mixes together in the reaction, but this won't participate in our mechanism of reaction at all. So, as you should know by now, we get anti-addition of our bromine and an alcohol. This is called a halohydrin addition, and I'm just going to go ahead and show you the answer right here, and then we're going to walk through it. So we get this here, where we have our 5-membered ring, and then we have an oxygen at the more substituted position, an alcohol, I'm sorry, and we have our bromine at the least substituted position. Then we would also have it's an antiomer. So now, why is this? Well, this proceeds through a pseudo carbocation mechanism. Remember, it forms that bromonium ion. So we have our Br2, that looks like this, and that bond comes and plucks one of them. And depending on how you're taught, the bromonium ion is formed immediately, or in some cases, it's taught that it is formed later after we form our carbocation first. But what happens, we have this where we have a carbocation right here, and we have a bromine. And this carbocation forms here because this is the most substituted position where it's more stable. And then you form what's called the bromonium ion, where it looks like this. And this is on the same face. So this is wedges at a positive charge. Now, these are resonance structures for each other. And so, while we know this bromonium ion exists because of the way it adds, because of the carbocation character that it has, this bond in particular right here is very weak. So we have our H2O come in, and this comes and attacks this position. But because these are on wedge bonds, these are one phase. So the bromine has to come in from, the oxygen has to come in from the other side to push it away. So we get a product that looks like this, more like intermediate product, I should say. We have our bromine facing away. We have H is H plus, or OH2 plus, and then the Br minus from 4, take this. That gives us this right here. Now we say the enantiomer forms because this bromonium ion could also form on wedge or bond dashes, the dash bonds, away from us. And then the oxygen would come into the plane of the board from us. So remember, halohydrin addition, Br2, and water, we get anti-addition of the bromine and the alcohol, and the alcohol's at the more substituted position. If you want to get more videos like this, hit that follow button. Drop a comment below what you're learning in organic chemistry. Send this to one of your buddies too.